part 2 of section 1.1, we're gonna learn a few different types of math statements. The first one is called a universal statement. And what is a universal statement? It is a statement that a certain property is true for all elements in a set. That's why we call it a universal statement. Okay, it's true for everyone in the universe. For example, if I look at the first statement here, I'll say all students taking this class info 2030 are smart. So do you see that this statement is saying, hey, this property being smart is true for everyone in a certain set. So the element in a set is like all students in this particular class. So this is a so-called universal statement. And universal statement, how do you identify it? Sometimes if you see it is true for everything, like all, and sometimes it doesn't have to have all. Take a look at this variation. We say every student taking info 2030 is smart. And this property is true for everyone in the class. So this is equivalent to say all. So this is a universal statement. The second statement is a conditional statement. Conditional statements is this structure. If one thing is true, so if this is the condition. This condition is this thing has to be true. When this thing is true, then some other thing also has to be true. Then this thing follow. Okay, so this is a conditional statement. If then statement is conditional statement. Now, if you are in info 2030, then you will have to do lots of homework. So this is conditional statements. If this condition is true, then this result will follow. Now the third statement says, given a property that may or may not be true, and existential statement says there is at least one thing for which the property mentioned is true. For instance, there is a student who is traveling today. So this traveling today, this property, we are going to say there is at least one student so that this property is true. So this is an existential statement. So how do we existential statements? There is, okay, this is. And the second one is not all students are in class today. That means that means not all students. That means that at least one student is not in class today, right? So that actually implies some students or at least one student not in class today. So these statements are called existential statements. Well, actually in our class, you don't just see simple statements like that. Most of the time, you may see those simple statements at the beginning, especially when we introduce the logic, the fundamental, the basic structure, you see those statements. But more often, the combinations of those statements. The first one is we combine the universal statement with the conditional statements, so which is called universal conditional statement. Now, the structure of universal conditional statement looks like this. For all, that's where the universal comes in. If then, that's where the conditional statement comes in. So when you combine them, it becomes universal conditional statement. And here's one. Universal conditional statements actually can be written into either universal statements or conditional statement only. So let's give a try, okay? Let's give a try. So in the this example, for all real numbers, if x is non-zero, then x squared is positive. So first of all, let's rewrite it without using variable. This is another objective that I want everybody to be able to do. So translate mathematical statement into a informal, everyday English statements. So take a look at universal only, okay? We can say, combine these two together. We say if x, well, without using variable, if this guy is non-zero and also a real number, so we are combining these two together. So we are going to say all non-zero and real numbers. And what's going to happen? This is going to be positive. What is positive? Its square is number. Its square is positive, right? So we can say that all non-zero real numbers has a positive square, right? Okay. So this is like converting a mathematical statement into a English statement that doesn't have any variable. And we can actually combine this into a conditional statement as well. So when we combine that into conditional statement, we're going to keep the if. We're going to keep the if. And then we'll combine the properties together. We'll combine these two properties together. So let's give a try. If, well, it has to be a real number. So a real number, and it has to be non-zero. So we are going to say if a real number is non-zero, then the following will happen. So then we are going to say its square is positive. Well, I have to say that, you know, different people say the same thing with different English statements, right? So I would say that I would not be surprised if you have different answers, but representing the same meaning, as then they will consider to be correct answers. So the answer usually is not unique. Now, let's rewrite these statements more mathematically. So like earlier, we translate that into universal statement only without using variable. Now let's use variable, but write the universal statements. So here, all non-zero real numbers. So, and I'm gonna give a variable there. So for all non-zero real number x, so the result is this x square is positive, right? So the x square is positive. Now, if we write the conditional only, again, we combine these two, but we keep the if. So we are going to say if x is real and not non-zero, so I'm going to say if x is not equal to 0 and x is real, in the future, we're going to say x is real number. This is the symbol, just heads up. We're going to use this symbol in the future to represent real number sets. Then x squared is positive, right? Square is positive. And if you want to be more mathematically, this actually, you can say x squared is greater than 0. That can be done as well. So this is one example of universal conditional statements. And the next one is universal existential statement. So we are going to combine universal and existential. If you recall, universal contains for all. existential contains there is. So the structure looks like this. For all, there is. Now, let's take a look at this example. Everyone dislikes someone. And how do we write that into, well, first of all, we want to identify this actually is a universal existential statement. So everyone, this is representing everybody. That's like all people, right? All people. So this kind of corresponding to universal. Dislikes is a verb, okay? And someone, that means somebody. There's some element. There is someone. So this is actually the existential. So this is a typical universal existential statement, but this is in a regular everyday English structure. Let's try to convert it into more mathematical sentence statements, or we call it. So here, everyone, that means, hey, I'm going to say for all people, because everyone means all people. And all people, this is a noun, and I'll introduce a variable. Let's call it S. Doesn't have to be X, doesn't have to be A. We can use any letter that you like. Let's use, say, S. And then existential, that there is. So I'm trying to match this format. So there is somebody, right? Someone. So there is someone. And then what is going on? This everyone, and everyone we use S to represent the everyone here, dislikes. So therefore, we are going to say for all people S, there is someone that S dislikes. Now, if you want to introduce another variable, we can actually, there is someone C, okay? There's someone C, such that S dislikes C. So now, for all people S, there is someone C, such that S dislikes C. And soon you will find that the is usually follows such that or so that. Usually we use such that more often. Now let's do one exercise. Again, I encourage you to pause the video and give a try yourself first, okay? So here we are gonna say every student has a favorite math teacher. So this is a typical universal existential statement, and universal because every student, right? A favorite math teacher, that's the existential piece. So now first statement is we are trying to get you familiar with, like comfortable with interchanging every and then all, like they're interchangeable basically. I'm going to say the first statement is all students have a favorite math teacher. So the goal here is to get you comfortable with interchanging every and all. Now let's try to introduce a variable. So for now, let's introduce one. For all students S, there is a math teacher who is like student S favorite. Well, you may have different structure, but as long as you have the same meaning, that will be good. And now some will say, well, why don't you introduce a variable for math teacher? Yes, that's what we are going to do in the third statement. For all student S, there is math M, and such that M is a S. Okay. Okay, so this is a few examples of universal existential statements. Now, we also have the last one, existential universal statements. You may think that they're the same, but in the future, we are going to talk about more of that, okay? So in the future, we are going to talk about that. The so-called existential universal, that means there is, that's corresponding to existential, some property, something that is true for all. So this is the universal part. For instance, there is a positive integer that is less than or equal to every positive integer. Okay, so this is there is you, and this every positive integer, that's universal. So this is an existential universal statement. Now let's rewrite it into like using some other language, some other different words. So there is a positive integer. That means there is some, right? There's some positive integer. So therefore, we are gonna interchange there is, change that to some. So the goal here again is to get you familiar with this change. So there is equivalent to some. Now, some integer, what is the property we're talking about? Is less than or equal to and every positive integer. So please make sure that you are able to convert, like change the is to some. Now, we can certainly, when we say some positive integer, that means, again, there is positive integer m. This time we are introducing a variable m such that for all positive integer, so this is another noun, we are going to introduce another noun. Let's use n. Introduce a variable for this noun, so n. And what's the property? This m is less than or equal to this n. Okay, so last one is right using variables. You're able to not is the positive integer. Are you able to find it? It is less than or equal to any other positive integer. So there is, this statement is true. Now, again, let's close this section by completing the last example. There is a student in Info 2030 who is at least as old as every student in class. Again, there is means existential. Students in class, that means universal. So this is a universal, existential universal statement. And then part A is to convert the is to some. So some students in Info 2030 is at least as old. Well, every student in class. So without introducing variable. Part B, there is a student S in Info 2030 such that, well, again, I want you to kind of like know what's happening here. So try to introduce variable for every student in class, for this every student, right? Such that for every student, I already used this, so I have to use some other variable. And what's the property? T. All right, that concludes this section.